Here we go. We're going to finish off this worksheet. I saved this as the second part because there's just a couple little, not tricky things, but things you have to kind of think about, new things you haven't seen before. So we're going to use u-substitution for all of these. 5 is the last indefinite integral we're doing, and then 6, 7, and 8 are definite integrals. I'm going to show you how to handle that. But this one, let's see. What do you suppose you should let u be? So you want to try to find the derivative in here, and unfortunately you can't really see a derivative when whatever you let u be, basically. So you might play around with that for a while, but you still make a choice. It's still going to work, and let me show you how. And generally it's better to let u be kind of the more complicated part. So I'm going to let u be x plus 2. Because then, if I want to rewrite this in terms of u, this would be the square root of u to the 1/2. So that's pretty easily written. The problem is this x, right? If that x wasn't there, I would be home free, ready to integrate. But there is an x there, so I'll show you how to handle that. We can still do this. Let's go ahead and find du. Du is going to be the derivative of this, which is just going to be dx. So by writing down du, I get the dx, okay, and the integral symbol's free. This would, to rewrite this portion, that's going to be u to the 1/2, but then we have this pesky x we have to account for. So let's go ahead and write this start down. The integral of du took care of these two things. This is about to be taken care of. I'm going to write that as u to the 1/2, and then this x still needs to be handled. What you can do sometimes is just simply solve for x in terms of u. Here's an equation with the x and a u in it. Let's get x by itself. We'll subtract 2 from both sides, and we get u minus 2 is equal to x. So that's excellent. Then we can just say, well, let's just directly substitute that in for x. So this is u minus 2. It's what that is. When I look up, I have completely accurately rewritten that integral in terms of u, and I'm ready to integrate. To integrate this, I'll distribute this to each side, to each term. So this is going to be the integral of u to the 1 times u to the 1/2, or u to the 3/2 minus 2u to the 1/2 du. I'm just distributing. I haven't integrated yet. As you can see, if you get tired, I'm a little bit tired, you can start to mix your methods, which is dangerous. So let's see, I'm just distributing this. Now I'm going to integrate. This becomes u to the 3/2 plus 1 over that number. So this would be u to the 3/2 plus 1, which is 5/2 divided by 5/2, or times 2/5, minus 2 times u to the 1/2 plus 1, 3/2 divided by 3/2, or times 2/3, plus a constant. So this is 2/5 u to the 5/2 minus 4/3 u to the 3/2 plus a constant. The last little step is to rewrite everybody in terms of the given variable, which was way up here, x. So u is equal to x plus 2, right? So this is really 2/5 times x plus 2 to the 5/2 power minus 4/3 times x plus 2 to the 3/2 power plus a constant. So this is what our final answer is for number 5. All right, cool. So now let us go ahead and look at definite integrals. So now it's not going to be so hard to figure out what to let u be, but we have to handle those limits right here, 0 and 3. So let's do something about this. If we have to integrate this, just go ahead and pretend like those limits aren't there. So we'll do that. If we had to integrate 1 over 5x plus 1 dx, which is the same thing as that, what will we let u be? And if this bothers you, the way this is written, you can just rewrite this as this, if that looks better to you. So I'm going to let u equal to 5x plus 1. And then if I take the derivative of u, du, I get 5 dx. And so what I need here is to rewrite this. I need a 1 over 5x plus 1, so that's going to be 1 over u. I just need a dx. I don't need a 5 dx, but that's easily handled by just dividing both sides by 5. All right, so now, here's my dx. This is my dx, okay. 1 over u, I think this is going to be fine. So let's look at this. This is the integral of 1 over 5x plus 1, or 1 over u, I need a du, so dx, so that's 1/5 du. This is this part rewritten. Now, the limits, right here, the limits, this is with respect to x. So what I'm going to do is change my limits with respect to u. How do I do that? Very easily. I take this 0, this value, and I plug it in for x here, and I figure out what u would be. So right here, 0. 5 times 0 is 0, plus 1 is 1. In this case, this lower limit would be changed to a 1. 3, right here. I would put 3 in u and figure out what that would be. 5 times 3 is 15, plus 1 is 16. These are my new limits that I have changed to be in terms of u. This is not the only way you can handle this problem, but this is the way I'm going to show you at first. Now we integrate with respect to u, and we plug these u limits in right there, and we do not have to change it back into x when we do it this way. So I'm going to do it both ways on this first problem just to show you what your choices are. So right here, what should we do to integrate this? 1 over u, the integration of this is the natural log of u. So this is 1/5. 1/5 times the natural log of u. Evaluated 1 to 16. I did not put absolute values on my u because I see these numbers are positive. I don't have to worry about that. I know what they are. So this is going to be 1/5 times the natural log of 16 minus the natural log of 1, but the natural log of 1 is 0, so this is just going to be the natural log of 16 over 5. That is my answer. Now, I'm going to spend a little time showing you an alternate way to handle these limits. Okay, let's see. This is an alternate way to handle these limits. We would still go through number 6. We would still say, okay, I've got to integrate this fella. I'm going to use u-substitution. I'm going to let u be this, d use this. I'm going to rewrite this guy in times with this. This is the only thing that changes. Right here, I just sort of take note that this was not an indefinite integral. There is a number that goes there. I just sort of hold off on that for a second, okay? So if I hold off on that for a second, this is, oh, I don't want to erase that. I want to remember what I got here, make sure I get the same thing. All right, this is what I got when I did it that way. Now I'm doing it another way. I'm gonna erase this part. Okay. What will I do from here on out? Okay, this is what I'll do. If I don't want to change my limits, I don't want to go through that, that's fine. Then I would just finish integrating, but remember that this is not an indefinite integral. I don't add a plus c, I integrate, and I get, this is 1/5 the natural log of u. All right. Then I say, okay, let's put this back in terms of x. Okay, so this is really 1/5 the natural log of 5x plus 1. Evaluated at the original limit, 0 to 3. And so then, once it's back in x, you can go ahead and use the x limits. And so that's going to be 1/5 times the natural log of 5 times 3 plus 1 is 16 minus the natural log of 5 times x is 0 plus 1, the natural log of 1. And you can see we're going to get the same thing. So, choices. Write it in terms of u, change your limits to terms of u, evaluate it without ever going back to x. Or, remember, it's a definite integral, put everything back in terms of x, and use your original x limits. 2 different ways to do it, your choice. Let's do 2 more examples, 7 and 8. See, 7 is right here. So, it is the integral from pi over 3 to 2 pi over 3 of cosecant squared of 1/2 t dt. That is the one we're looking at now. So, let's see. What do you guys think we should let u be to be able to evaluate this? And so, if this was just simply cosecant squared of x, I could figure that out because the derivative of, what is it? Cotangent is negative cosecant squared. So this I could get back pretty easily if this was not this 1/2 t. Well, if I let u be 1/2 t, then that might clear things up for me in a big way. So let's explore. Okay, let's see. Let's let u equal to 1/2 t. And then when we take du, that's going to be 1/2 dt. What I need here is not a 1/2 dt, but just dt. So I could just multiply both sides by 2 du, and that gives me the dt. Let's see. dt, all right, is taken care of by writing down 2 du. The integration symbol's free. And then I can say this is the cosecant squared of u. So that's going to work. Let's rewrite this. I'm kind of, because of the space on the board, I kind of did this backwards. So let's go up here. So this is going to be the integral symbol. When I write down 2 du, what did that account for? That took care of dt. Now I need to write the cosecant squared of 1/2 t, but 1/2 t is u. All right, here's where we have choices. You can either substitute this in. Where? I'm going to substitute this in for u. So if I let u is equal to 1/2 t. So let me show you here. My upper limit, my lower limit. I could substitute in that. So let's see. 2 pi over 3, 1/2 times 2 pi over 3 gives me pi over 3. So if I was going to rewrite my upper limit, it would turn into pi over 3. If I was going to rewrite my lower limit, this would be 1/2 times pi over 3, and that turns into pi over 6. So I am choosing to rewrite everything in terms of u. I will not go back to t. I'm going to evaluate it because I've adjusted my limits. So let's take this integration. What can you take the whose derivative is cosecant squared? Nobody's, but the derivative of cotangent is negative cosecant squared. So if we tack a negative on, we're in business. So this will be -2 cotangent of u is the antiderivative here that we get. And then we're going to evaluate this. Pi over 6. The upper limit is pi over 3, and the lower limit is pi over 6. So this is going to be -2 times the cotangent of pi over 3 minus the cotangent of pi over 6. So let's look at our unit circle. This is pi over 6. This is pi over 3. The coordinates here are square root of 3 over 2, 1/2. The coordinates here are 1/2, square root of 3 over 2. Cotangent is cosine over sine. So, cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. So, cosine over sine, if I flip this, is going to be 1 over the square root of 3. Okay, -2. And this is minus the cotangent of pi over 6. So the cotangent of pi over 6 is sine over cosine. No, sorry, cosine over sine. So that's going to be square root of 3 over 1 minus the square root of 3. So that is what I get there. Let me make some space. Now that that's my unit circle, remembering what these values are. So this is basically, I can distribute the 2. This would be -2 over the square root of 3 plus 2 square root of 3. And that is the answer that I got for number 7. I think I made a mistake when I worked this out earlier. Because I surely did. I threw a little squared on there when I shouldn't have. So I feel okay about that answer. Let's look at number 8. Last one. Let me write it up here. From 0 to 1 of x e to the negative x squared dx. So, what should we let u be? Let's see. Can we see anybody's derivative up there? This is what's coming to my mind. If I let u be negative x squared. The derivative of that would be -2x, which is not quite x, but that negative 2 can be so easily adjusted just by dividing it out. So I think I'm going to go with that. Let's let u equal to negative x squared. Then du will be negative 2x dx. Why is that helpful? Oh, because I see x dx right there. And if I need to get rid of that negative 2, I can divide both sides by negative 2. So negative 1/2 du is x dx. So that took care of a lot. Can I rewrite e to the negative x as e to something in terms of u? Yes, because that's what I let u be. So let's rewrite this. This is the integral. Negative 1/2. I always like to put my constant out there. You don't have to, but that's just where I am comfortable putting it. Negative 1/2 du. What did that take care of for me? It took care of the x dx. So this is taken care of, and that's taken care of. Now I need to take care of this, and that's just going to be the base e raised to negative x squared raised to the u. That is all taken care of. You can adjust your limits, right? We could go in here and say, here's u, let's let x be 0. 0 squared is 0 times negative 1 is 0. My new u limit is 0. 1, and for x squared, 1 squared is 1 times negative 1 is a negative 1. We've adjusted our limits. Once you've done that, you do not have to go back to terms of x if you do it there. Or you could put everything back in terms of x and put in the original limits. Let's do this. This is negative 1/2. The integral of e to the u is e to the u. And we're going to evaluate this, 0, negative 1. So this is negative 1/2 e to the negative 1 minus e to the 0. This is negative 1 over 2e. This is minus, this is a 1, right? E to the 0 is a 1. Plus 1/2. This is what I get for my answer right there. All right, that is how you can do substitution rule. There's plenty of homework for you guys to practice on.